Okay, so I'm going to talk to you a little bit about some work that USGS is doing related to the detection and attribution of inland flood change across the United States. So I added the inland post abstract submission just to emphasize that that's what we're talking about, not coastal flooding, coastal river flooding. So as some of you, most of you may probably already know, the USGS has had a long history of involvement in floods and flood research. So some of the things that USGS does related to floods is we measure and report flood flows and water levels in real time. And we had a great presentation earlier by the USGS on how a stream gauge works and the type of information that's collected and how that may relate to floods. Then we keep a historical database to access flood risk throughout the nation. So we use this historical database of floods to build relationships that tell us things about flood frequency across the United States at rivers. We also use this information to enhance our understanding of flood risk to support public and private decisions. So again, an example from the talk earlier this afternoon was on flood inundation mapping, but we do a number of other activities in that area. So, and how do we deliver this information? So we have 8,000 stream gauges across the United States where we have this type of information. We describe flood frequency at gauge sites, and we develop regional statistical relationships that give us estimates of flood frequencies when we don't have gauge data available. And that's delivered through our USGS StreamStats website. It's a point-and-click tool where you can click on any river and then obtain river statistics, frequency statistics for that river. So up until this point in time, the analysis of floods has really assumed stationarity, meaning that we assume that the past is a reasonable representation of the future. So the data that we've collected historically, if we use that to estimate flood frequencies, then we assume that that is an adequate representation of what is going to be happening in the future, the types of flood frequencies we can expect. But we have all, so my bias is I'm a hydrologist, not a hydraulic engineer. Don't hold that against me. But I mean, I would say hydrologists, hydraulic engineers, we've all long recognized, right, that the potential for trends and floods already exists due to a number of things such as urbanization, deforestation, and artificial land drainage. And then more recently, hydrologists or hydrologic engineers have been looking into what effect climate variation or change might have on floods, and how do we incorporate that into our flood risk and our decision making. And so there's been a number of studies done on this topic, and I'm just putting some three main graphics from USGS related work in this area. The first one is a paper by Hirsch and Ryberg. Then we have another paper by myself and several co-authors looking at flood change in a different way. And then we have a third paper by Hodgkins et al. That just came out in 2017. So there's been a progression over the years, particularly in USGS research, looking at different aspects of flood change. And what they all tend to show is that there's a mix of increases and decreases, and some parts of the country are experiencing no change over the historical period. And so the question then becomes, well, what do we do when we have these, what we call it in one of the papers, fragmented patterns of flood change, and how do we address that in the information that we provide as the USGS? So if a trend is observed, what is the course of action then? Well, so Bulletin 17C is the most recent report that's come out from the USGS, but it's a number of agencies and other academic and consulting places have contributed to this document on a new updated approach to estimating flood frequencies in the United States. And Will Thomas tomorrow morning is going to be giving a workshop on the Bulletin 17C and the advancements that have come out of the most recent documentation and the tools that are available to compute flood frequencies using this new, some of these newer methodologies or updated methodologies. But there is a statement in Bulletin 17C that actually addresses directly the question of flood change and what to do. So I'll read it. There's much concern about changes in flood risk associated with climate variability and long-term climate change. In those situations where there is sufficient scientific evidence to facilitate quantification of the impact of climate variability or change in flood risk, this knowledge should be incorporated in flood frequency analysis. All such methods, though, need to be that are employed need to be thoroughly documented and justified in order to make those adjustments. And so if you kind of pick apart this statement, there's several research questions embedded in that. First of all, the questions are, where is flood change happening? how are floods changing and what is causing the change. That gets at providing sufficient scientific evidence to quantify the impact of climate variability or change in flood risk. And then, of course, the actionable part is, if we do know the answer to these questions, then how do we actually make the adjustments for flood frequency under observed changes that we've seen in our historical data? And so this is generally the approach USGS is taking, which is looking at where change is happening, understanding how they're changing, what is the magnitude of change, understanding what is the causes of those changes. It might not be climate, it could be urbanization, it could be artificial land drainage, it could be a dam was installed at some point in time. And then looking to, once we know those pieces of information, asking how do we actually, what is the most promising ways to adjust for flood frequency. And there's other recent statements now in the literature. There's been a growing literature that is supporting this type of approach, and I'll just put up 3 different papers. There's a recent review paper by some of the names you might recognize here, Pepe Salas, Obey, and Rich Vogel from Tufts University. This is really talking about the complexities that come when you don't understand the mechanism for flood change, the caution about extrapolation when you don't have an attributable cause of that change, and then the uncertainties that are associated inherently with making any adjustments for the future. One of the outcomes from this paper, one of their suggestions, is that perhaps we need to be designing on shorter design timelines rather than trying to extrapolate information so far out into the future when we're so uncertain about how things might change, and even in the short term. This is an interesting paper that is by a colleague in statistical hydrology, Saranaldi et al. And this really talks about the dangers of just using trend analysis, hypothesis testing to make some assumptions about where change is happening. And again, the paper argues that while hypothesis testing of trends is important, it's really defining mechanistic reasons for why we see that change is going to be the most fruitful path towards making adjustments for change. And then lastly, this was a really interesting paper, a little bit older, that came out that just talked about looking at a set of design experiments where they extrapolate trends far into the future. And they actually found that using a trend, using flood frequency estimates that have been updated just to the current conditions provides better estimates than trying to extrapolate a trend off into the future when you don't actually know what direction that trend is going to take. So these papers are really just to point out that there's a growing literature really talking about this approach of understanding where change is happening, but then really being able to attribute that change before you make decisions about how you're going to adjust for it. And so when we move from detecting change to attribution of change, I wanted to just give you some thoughts about where some of the broader research, knowledge is when we talk about attribution of change, specifically with flood change and attribution as it relates to climate. So the IPCC AR5 report, they had a synthesis report of the AR5 findings in 2014. And talks about the fact that there's low confidence that anthropogenic climate change has affected the frequency and magnitude of fluvial floods on a global scale. And so they talk about how floods are generally more strongly influenced by the human activities on the landscape, and that makes attribution of detected changes more difficult. We have the NCA4 report that just came out in 2017, the National Climate Assessment, that actually corroborates a lot of what IPCC AR5 synthesis report says, that detectable changes have occurred in parts of the United States, but they're a mix of increases and decreases. Formal attribution methods have not established a significant correlation between riverine flooding to human-induced climate change. And then lastly, the National Academies weighed in on this in 2015, saying science is currently unable to provide reliable forecasts of the types and direction of change that may occur on any river or in any given community. So that doesn't sound like very, exciting in terms of where the state of science is at right now, or satisfying is the word I'm looking for, in terms of where the state of the science is in terms of what we can do about observable trends in floods and how we move forward, knowing we have to make decisions. And here's just 2 very simple examples of different flood mechanisms causing these large changes in peaks. So we see on the left, we see a site in Maryland. These are annual peak flows over a particular long period of time from 1940 to 2009. And then on the right-hand side, we see a site in North Dakota. And while it looks like there's dramatic increases going on in both cases, the mechanisms causing these changes are very different. In fact, in Maryland, we know that there's been a huge trend in urbanization in that basin, and that we can probably likely think about the fact that these changes are being brought about not by climate, but really by what's happening to the basin on the landscape. But on the right, there's a more complicated picture for those who may be located in the Midwest and familiar with some of the complex flood hydrology that's happening there, is that we don't really understand why floods are increasing necessarily yet. There's been some work that's been done on this, but there hasn't been really a definitive smoking gun. And it's some combination probably of climate and land use drivers that are driving these particular trends in floods. So to kind of address this question, the USGS and the Federal Highway Agency has entered into an interagency agreement to try to look at some of these questions. And I have the top research questions kind of organized as Bulletin 17C as our guiding principles for how we are driving this project. And we have a large number of people working on the project. They're not all fully funded. And they're located all across the United States to try to bring some of that regional knowledge of flood attribution. Just myself sitting in Reston, Virginia, I'm not going to really be aware of the types of flood mechanisms that might be causing changes in floods somewhere else in the United States. So it was really important for us to bring in the wealth of regional experts we have in the USGS. And so in terms of what we're doing with where is flood happening and how are floods changing, we're looking at monotonic trends in floods. It doesn't necessarily have to be a linear trend. It just has to be some type of increase or decrease with time. Doesn't matter what the shape is. We're looking at step trends. So was there just a change, like an abrupt change, say in a particular year, where the whole system just either increased in floods, the mean of those floods increased or decreased. And then we're looking at a peaks over threshold approach, where we look at floods that have occurred 2 events in 1 year, and then more rare events, which is 1 flood event per every 5 years. And then in terms of what's causing the change, what we're looking at right now is national data sets of dams, land cover change, and precipitation to develop and test hypotheses for causal attribution of observed changes. And then lastly, in terms of how we're going to actually adjust for flood frequencies for changes, we're looking to develop an assessment framework that's going to be able to evaluate all the different approaches that are currently out there for trend adjustment, because there are some methodologies that are becoming used. We're going to do that against idealized experiments where we know what the true flood is. We know that it has some type of trend involved in it, and then we're going to see how well these methods compare. So really what the project boils down to is detection of trends, attribution of trends, and then adjustment for trends. And then I'm just going to get into exposure to some of the work that we're already doing on this topic, so to give you some sense for that. But just it was more important for me I really wanted to convey kind of the broad overview of maybe why the science hasn't moved to a satisfactory place yet on this topic. So we started with a set of stream gauges in the United States. All of these stream gauges, these 3,500 stream gauges, have at least 20 years of record, complete record, at some point over their life of the stream gauge. Then what we did was we narrowed that down to choosing only gauges that had complete record. Well, they had to have 80% every decade of complete record over 50 years. And then that gave us 2,600 gauges. Then we further whittled that down to look at a longer time span of 75 gauges. Those are shown in green. So you can see the number of gauges in each of these periods of record is decreasing because there's less and less gauges that have been operating for longer and longer times. And then we also looked at gauges that were in existence for 100 years. Those are shown in red on the bottom right-hand corner. And we analyzed trends in each one of these different periods. I'm only going to focus on showing you the results for the 75-year period of record that we have. One of the other things we did was we did not screen out gauges that had urbanization, dams, or those types of aspects, because we wanted to include those in the data set to see if we could make some attributional statements about that. So here's an example of a trend analysis. This is just common Mann-Kendall monotonic trend analysis for anyone who is interested in the guts of it. So in the top left, the all shows all of those gauges that existed for the 75 period of record, assuming our completeness criteria. And you can see this kind of pretty typical of what you would see of other trend papers is these mix of increases and downcreases, although there is strong regional cohesion in the Northeast, in the central United States, and in the Pacific Northwest, we see a propensity for increasing floods, annual peaks over time. If we isolate only the HCDN gauges, so that's in the top right-hand corner, those are gauges that would have limited regulation or limited basin alteration, so we can consider them more like indicative of what might be happening in the climate. We see a mix of increases and decreases, but there's a little bit of gauges here, and we do see, again, the strong pattern in the Northeast, the central U.S., and the Pacific Northwest of increases in general in annual peaks. If we move down to the urban side of things, there's far fewer gauges that we were able to just isolate for effects of urbanization, taking out effects of other gauges. But we can see urbanization generally has led, in this case, to increases in floods for those particular gauges. And then if we move to the regulated dams, we can see that, particularly in the western United States, it seems that dams have generally brought about, as we might expect, a decrease in flood magnitudes over the course of these 75 years. And so this was kind of our starting point for attribution. We did one other analysis, which is to look at, like I said, these change points. So we looked at where in our 75-year period did a particular site experience a change in the mean of the annual peaks. So that would be just, instead of like a gradual trend, it would just be in a particular year, there was an abrupt change, increase or decrease from previous conditions. And I'm just going to show you a little animation. If I can get it started. I swear I tried this before. Let's see if it's going to work. Sorry, maybe I didn't do that. Oh, I might be. So I don't want to waste too much time. Yeah, that's what I'm wondering. How do I do that? Sorry, everybody. I practiced for everything but this. Maybe there we go. Okay, let's see. It might start. Yep, okay. So what you're seeing is as the years tick by in the upper left corner, you can see all the gauges. And gauges will turn on when a change point is detected. Red is down. That means there's been a decrease. And in that year, there's been a decrease from the previous, a decrease in the mean of the floods post and pre. And then the blues indicate there's been a step change in that year of an increase of floods to kind of this new regime of floods. And so as we go through, you can see in the late 60s, in the eastern United States, in the 70s, this is well documented. There was a large increase in floods. And then as we move forward in time towards the late 70s and early 80s, then we start to see in the western United States, we start to see a lot of decreases, step changes and decreases. That could maybe be because a dam had gone in or something to that effect. And so this is just another piece of information that we have to try to then work on attributing why we see these changes, why they might be occurring. So I'll end there. Let's see if I can move on to the next slide. Okay, so then in terms of our next steps in this is, so then what we've done is this figure showing here is showing the now gauge boundaries for all of the gauges that fall within that 75-year criteria. And we've divided now the country into, 7 regions. And we have teams of people working in those 7 regions who have more intimate knowledge of the types of factors that may cause changes in floods. So the hydrologic technicians that work in that office, the research scientists that work in that office, we're engaging their expertise to try to understand what's happening at a particular gauge. So each of these regions have received the gauges that fall within that particular region, as well as the trend detection results. So they know where there's change occurring in each of the gauges in their region. And then they're also receiving national data sets of time series of changes in basin characteristics that might be able to be related. So things like years that dams got put in, or precipitation data would be an example of something else, or urbanization land cover data that's changing with time. And what we're asking each of those regions to do then is to take each one of those gauges and compare that to what might be a possible realm of explainers or attributors to the trends that they're observing. So they're taking the data, then the gauged information from the trend detection. They're looking for which gauges had detectable trends, either a step trend, an abrupt change, or a monotonic trend. And then they're using these national land cover data sets, or not just land cover, I'm sorry, these national data sets to actually look at all of the many drivers that we have here. Some of these drivers we don't have data for, but we started with kind of the whole universe of possible effects on floods, and now we're whittling our way down to see what we have data for. I just wanted to mention that the study is limited to national level analyses using attribution characteristics available at the national scale. So some of the DOTs in the room may have been in conversations with USGS personnel about specific flood change studies. And that is, I think there's a lot of benefit to that because there's a lot of data sets that might be available on a regional scale that are not available at a national scale that could actually be utilized in more detailed studies. And I just want to say that's a limitation of this particular study because we're looking at things that are only available nationally. And so just to give you an example of what we hope are some of the outcomes from this, so we're gonna, each stream gauge is gonna have a primary and secondary attribution assigned to it with a statement of confidence as well. So we have a lot of examples from the climate literature about statements of confidence. Something's probably likely, very likely, not so likely. This is just one example from a climate assessment report giving things like whether you have, how much evidence you have and whether the agreement, if there's high agreement between a causal factor and say flood change, and then whether you have the evidence to support that. So we're putting the attributional statements on kind of a scale. We're finalizing what those statements are actually going to be. This is just an example. We're kind of knee deep in the middle of this attribution exercise right now. But the goal is going to be a table that looks something like this. This is just an idealized table where you'll have a list of gauges for every region. You'll have other information, what the trend was, the direction of the trend. But then you'll have a preliminary attribution column, a primary and a secondary. And then you're going to have the statement of confidence, how confident the hydrologist working on this project was that it's attributable to those two causes, and then notes that would support the attribution statements that they've made. And so just to wrap up, the expected products and next steps. So in terms of detection, we have a number of papers now in review or in process on monotonic trends, step trends, the regional variability of flood peaks, and then we're doing some work additionally on the frequency and occurrence of extreme floods. When it comes to attribution, we're expanding a national database, a USGS national database to understand causes of flood change. And then we're going to have a publication from each region on their attributions of flood change, and then a national synthesis that's going to kind of roll up what commonalities we might have seen in the regions related to this. And then lastly, we're in year 2 of 3 years, so we haven't gotten started yet on this, is we're going to do an evaluation of currently proposed methods to adjust flood frequencies and identify the most promising methods to adjust for change, and then establish a framework so that as people come up with new ideas for this, we would be able to kind of evaluate that against the other methods in a framework type approach. So I think I went pretty over, Brian, I'm not sure.
Luckily,
Sorry.
yeah, luckily I started 5 minutes early.
Sorry, I'm so sorry. That was very
no,
greedy of me.
there's a lot of information.
I apologize.
A lot of information.
So that's what USGS is doing right now related to flood change.
So 3 years, when's the project going to be completely done?
So we're in year 2. The hope is that the attribution analysis, the preliminary, will be done. These statements will be done by the end of October, and then we're hoping publications coming out after that. So I guess another year we would have for, for getting publications ready, and then the adjustment piece too. So I would say stay tuned for maybe another year or 2 for final completion. Some stuff will be coming out even sooner than that, the detection stuff, papers.
So all the speakers are going to be sticking around for a panel session, but if there's some questions specifically burning about Stacey's information.
Yes.
I thought when you started you were going to be using the sites that didn't have urbanization and regulation, but the 1,464 sites for the 7 regions, they do have urbanization in them because you showed separate slides for urbanization.
Yes.
You just chose 1,464 sites that had at least 75 years of record.
That's correct, yes. And then the way we did the urbanizations, we did carefully try to screen out to make sure they were only urbanization and they didn't have confounding effective dams. Yeah, we tried to do that screening level. When I say we, my colleagues Rob Dudley and Glenn Hodgkins were the ones who did that, but yes, yeah. Okay.
I don't know if you need the mic, but Stacey, when you're saying dams, are you including stormwater ponds in that? I know a few years ago, there was concern that stormwater ponds are creating extended detention, maybe not necessarily peak flows, but that was related to channel forming discharge, and I don't know where that falls in your flood.
Yeah. Excellent question. So right now we're only using the dams available in the National Inventory of Dams. So I'm guessing it does not include those types of ponds. But that would be something like if you know in a particular region that you're in that may be a confounding effect, that would be where regional knowledge or like local data sets would enhance the type of work we're doing. Yeah. Sure. Okay. I seem to have lost the mouse. Okay. We can
Okay.
get on to the next talk if I find the mouse here.
Well, thank you, Stacey.